Hey friends, welcome back to a new week of science learning. This week we're learning about properties of matter. This reading passage is posted in the Monday folder for you to read, and I want you to take some notes. Take a photo of your notes and then upload them for me to look at. When you upload your notes, I want you to think about whether or not your notes reflect knowledge of what you read and whether or not your notes reflect the fact that you have watched and understood this video. I'm going to show you a strategy for taking notes that will work with any kind of subject matter, whether it's something you're reading for science, social studies, if you're reading a newspaper article, pretty much any kind of school-related nonfiction reading, this is a good strategy. So these notes are called, I think they're called Cornell Notes because they were probably developed at Cornell University, which is a college in New York. And the way Cornell Notes work is you just use a regular sheet of white-lined paper, or you could do it in your science notebook. And actually, I would suggest doing it in your science notebook because that way all of your notes stay together. We're going to divide up our paper. We're going to have a smaller space on the left side, and that's where we're going to write our questions. These can be questions that you are wondering and want to learn more about, or they could be teacher-like questions, questions that you imagine maybe your teacher might ask you about the material on a quiz or something. So on the left side, we're going to have questions, and then on the other side, we're going to write our important ideas. Facts and vocabulary. So that's why we need so much more space on this side of our paper, because this is where we're really going to put the majority of our writing. The questions will serve as a record of things we're still unclear about and as a way to test our knowledge, because when you're done with the passage, if you should be able to answer at least the basic teacher-like questions. I'm going to switch to black ink because I think that will be better for you guys. Okay, and then down at the bottom, we'll have one last section, and that will be for our summary. A summary is a 1 or 2 sentence wrap up of the most important idea that you learned, like the main idea. Okay, so those are our 3 parts: questions, important ideas, facts and vocabulary, and summary. Let's go ahead and read. What are the differences between solids, liquids, and gases? Right away, I noticed the word differences, and it kind of gives me a heads up that I'm going to be learning how things are alike and how they're different. Remember that everything you see, including yourself, is a form of matter. Does water have matter? You bet. Matter is anything that takes up space and has mass. I'm going to write that down. That is a big important idea that we're going to keep repeating over and over again in 5th grade. Matter is anything that takes up space and has mass. This word mass, I'm going to underline. That's an important vocabulary word, and a lot of people think that mass is the same as weight, but they are actually different. I'm just going to kind of stick that down here as a reminder to myself to come back to it. Matter is made up of small particles. Matter is a solid, liquid, or gas based on how fast these particles are moving around. Solid, when the particles that make up an object are so close together, they cannot move around. So when we say particles, we're talking about things that, little tiny pieces of matter that are so tiny that you definitely could not see them with your naked eye, and you definitely could not see them unless you had a microscope that could zoom in to more than like 10 million times. So these are tiny particles. So I'm gonna imagine like a baby wooden block, you know? Babies play with these blocks that have the letters of the alphabet on them. This is my solid. The particles that make up a solid are so tightly packed together that they can't move, and that is why they have the property of being solid. Okay, now on my little baby wooden block here, I'm going to draw these little tiny dots. These are meant to be my particles. They're very close together. Not really moving around at all. Tightly packed, very little movement. Liquid, when the particles that make up an object are close together, but they can still move or slide around one another. So for this one, I'm going to draw a glass of water. See, here's the water, the rippling water. Oh, I forgot to label this. Solid, particles are tightly packed. Liquid, particles are close together, but can still slip and slide past each other. So for these particles, I'm going to draw them with more space in between. Okay, now as you read, pause every once in a while and think of a question. It could either be something that's confusing to you, something you want to learn more about, or it could be, like I said, a teacher-like question. So I'm going to say, how are the particles in a solid and a liquid different from each other? This is my teacher-like question. And I'm able to answer this question because I've read and understood the passage. They're different from each other because in a solid, they're very close together and not moving very much at all. Whereas in a liquid, they are still close together, but they are able to slip and slide past each other.